Hello friends, my name is Paul, Oscar Mike Zero Echo Tango, and welcome to my new video about my new little homemade project. And today it will be a high voltage homemade tester of these little variable air capacitors, which I usually use in my maglev antennas. Okay, as you see, there is a little space between the plates, and sometimes these capacitors came to me in not a pretty good shape. That means that sometimes between the plates is dust or some kind of debris, which makes many shortage between the plates, and it make of course a problem with the magnetic loop while transmitting or receiving, of course. So first thing what I do is that I use my compressed gas like this, the gas duster spray, and of course I will remove the dust this way, and mostly the debris will be removed very quickly. But sometimes is it not so easy, and before the build of my antennas I need to test if any capacitor is 100% okay. So for this I will need my homemade little tool, and it will be the high voltage tester. For this thing I will use this little cheap lighter, which is powered by 1.5 volt AA battery here, and is doing something like this. Yeah, it looks like a paralyzer. Okay, and now I will open this thing. I will remove the electronic from the inside of this body, and then I will make my first high voltage tester of this capacitor. I will use this plastic board and will cut it to small pieces. Then I will use these screws with the wires, and the electricity will spark here in the middle, and I will use these probes with the crocodiles, and I will join the crocodiles here right on the capacitor pins. Okay, and then I also will use these banana sockets for good connection of these probes. So here is my schematic diagram plan. So my high voltage tester will consist of two pairs of sparking tips. It is a serial connection of two pairs of sparking tips. So the one pair and the second pair. The first one will be or will represent the variable capacitor, and the second one will be adjustable by the screw, and the gap will be changeable between them. I want to try firstly to connect in the serial fashion, to the high voltage generator. And the second pole will be connected to the capacitor. Here will be the screw, which I will adjust the gap between two tips. Okay, so firstly I have to make a base of the plastic board. Then I will need two small pieces of this same plastic board, and here will be connected one pair of the sparking tips. Okay, so here will be the PCB board with the high voltage generator and also battery. Here in the middle I will drill holes through and in line. So here inside of these holes I will place these screws with the wires, and the wires I will connect right here to the board. So one pole of the generator will be connected to the screw here. The other screw is here. Voltage will penetrate the air between these gaps to the other side, and I will connect here the banana socket. Also here will be banana socket. From the banana socket I will line the capacitor, and the second side of the capacitor will go here to the second banana socket, and from the second banana socket I will line here the wire to the main board. So that's the plan, and I hope that it will work. Now 2 holes for banana sockets. Okay, so the parts for the base are finished, and now we have to disassemble this lighter. We need to know how long will be the PCB inside, because we need to calculate space on the plastic board here. We need some space for the PCB board, and also we have some space here between the sparking tips. So let's look inside. Okay, here we go. The PCB board. And battery. So here on the board we need such space like this, and so. Okay, so now let's calculate and mount these two boards on it. So this is the maximum position for these two supporting boards, and I will fix this little plastics here on this place, and here's this will be the maximum or the minimum gap between two screws, and after all I will adjusting this screw for its ideal position while testing. So now I'm going to fix this little plastic to the board or the base plate. So I have marked a center position for the fixing screws here and also here. With the screws we'll fix the boards together, and now I will pre-drill the holes for the screws. As you see, fixing failed in this case. Okay, the second try. Okay, so the board is finished. Now I have to continue with fixing the board here, and I have plugged in the sockets for bananas, and then it should work. I made the wirings as you can see here, we have two wires. One is let's say positive, one is a negative. Is it not really true because there is no any DC. So here we have wiring is going through the hole here to the second plate with the banana socket. Yes, you can see that here. And I have connected here the crocodile. Okay. And here between these two screws I will use this another one, which will be adjustable, and this little gap is now adjustable, so I can very closely adjust the distance between two tips. Okay, so this stage is complete. Now it's time for electronics. I made the wirings on this PCB board with a high voltage generator, and here I removed the old switch over here, and I made these wirings, and also I added this 3-volt battery here and here, and also drilled these 2 holes. I will fix this PCB here on this place with 2 screws, and also I will use this little switch for power on this device. So now I will complete this device and hopefully it will work. Good, so output wires soldered, and now let me finish this project. I will fix this PCB board on its place, and now just the final thing is to fix this little switch on its place. Okay, so device high voltage tester is complete, is finished now, and actually it should work. So for the first test I will need to shortening these 2 sockets with this jumper with banana plugs. By the way, here will be connected the air capacitor, which is tested. Here we have the maximum gap right now, but we can adjust this more. I have to cut this screw, and then is everything complete, so we can switch the button and see what will happen. And it's working. It's really working, so that's good. Yeah. Great. And this is an update I did on this device. The first update is to exchange the battery. Previously I used a 3-volt battery, but due to very high current consumption of this device, I had to change the battery for this one. This is rechargeable battery, but it's still not okay, and yeah, I have to replace this battery for an external power supply. So you can see here I will use this 3-volt power supply unit, and I will use, of course, the DC socket and the box for the DC socket, and also I have to remove this old black box for this one, and here I will mount the power switch, and then I will have to place this thing here on this side. And the other modification is wirings. Previously you have seen a serial fashion wirings. So here we have 2 poles like here and here, and you can see the black wire coming through the plastic to this pad like here, but also it goes to this through this wire here and here. The second, the blue wire is coming here to this pole, and then goes here to the second pad for testing. So this is the parallel fashion, so the same voltage here and same voltage here. Here I will measure the capacitor, and here I will see the sparks. Okay, so now I go to make this modification for the external power supply, and hopefully it will work. Okay, it fits perfectly. So now I have to clean that. Okay, it's clean and perfectly fit here. Yeah, it's a little bigger, the hole, but don't worry. And the holes for tiny screws. Okay, screws on place, and now I have to make a second hole here, not here, but here. Here will be the button, or here the power switch. And this is the place for this power switch button here. So now I have to drill the center hole and then make this place for the power switch. Okay, good. So fitting fine here. So now I have to clean that and make wirings inside this little box. Okay. Okay, box is cleaned, and now I need here 2 holes for the input-output wires, somewhere here and here. So these 2 wires will go through these little holes. Okay, just have to finish the wirings and soldering job. Very good. So as you can see, inside is very simple connection. Here is the negative wiring here, and the positive wire here, right through the switch, goes to the PCB board. So we have the socket for this 3-volt adapter, and little switch. Okay, and we'll close, and I'm going to test. Finished. So now we can turn it on and we'll see if it works. Okay, so everything is ready and device is powered on by adapter, 3 volts by the way. So again, I'm using now the parallel fashion, like parallel connection between this gap and the gap between capacitor plates. So the same voltage will be here on these terminals and here. The functionality of this measuring should be like that. We have two high voltage poles or high voltage here from this generator, and between the poles here are two gaps. This side is the device gap, it's here. So let's say it's a meter, and here will be the capacitor gap between the plates or connection on these terminals. So it should be the gap between two capacitor plates, or this gap should be bigger than the gap on device. Okay, so if the gap goes to smaller than this one, the electricity will burn here or sparkling here. So how we can see if the capacitor is in shortage or not? Again, so the gap here have to be bigger on capacitor plates than the gap on the device, on the meter. Then the sparks will be here, only here, not here. Here will be only when the gap will be smaller than this gap here on the meter. Sparks will appear here, but disappear here. And then we know that something is wrong with the capacitor plates, and we have to repair the cap, or we have to use dust air and clean the plates or the space between the plates on the capacitor. Okay, so this device is powered on my external 3-volt power supply. Now I will switch on the device and see the high voltage here. Okay, and you can connect terminals. I hope I will be not hit by these things. And now we'll see. You see that if the sparks are here, they are not here, or they are here, they are not here. That is correct. Okay, so definitely this device is working fine, and I hope it will help me with my, for example, magnetic loop projects, and to resolve the problems with the capacitor sometimes. Okay, so I'm very happy that this little device works. It really works. Yeah, it looks like a little paralyzer. Okay, so if you like this project, leave a comment or hit the like button. Or if you like my videos, please don't forget to subscribe to my channel. Thank you very much for watching this video. I hope you will enjoy, and we'll see you again next time. So 7-3, bye bye.